also be lipid component, hydrocarbon, glycoside, and vitamins. Okay. These are all, although they are minor, but they are all under category of lipids, under category of lipids, but they are very minor. Okay. And then we go to fatty acids. Okay, fatty acids. So the way you write fatty acids is COOH, C double bond OH. So this is the carboxylic group. Carboxylic group COOH, the one that we write. So COOH, the C, they are the double bond with O, and then with hydroxyl group lah. So this hydroxyl or carboxylic acid group has this hydrophilic head group. So whenever you see a compound with an OH, normally they are more hydrophilic. Okay, and then we have R group. Okay, R group ni is the one that confer the non-polar hydrophobic part of the lipid. Okay, so dia akan ada yang the end tu, dia ada just like protein, right? Protein, if you can still remember what Prof taught you. Protein has the CN dengan the carbon N, or we call it the C terminal. We also have the N terminal then, because amino acid, right? Amino acid has amino group dengan acid group, right? So that's why it is called amino acid. Okay, because we have the carboxylic acid group, we have the amino group. Okay, and then when they combine together, so we call it N terminal dengan C terminal. Okay. So this one pun sama. So we have an carboxylic acid terminal, but in fact we don't call it terminal, we call it group lah. Okay, carboxylic acid group. And we have the R group. So this carboxylic acid, because of the OH, these are the one that gives you the head. The head tu yang duduk kalau kat membrane, the head tu yang duduk kat luar. Kan? The tail yang, so if the membrane is double layer, right? So you have the head is the hydrophilic part, and then the tail is the hydrophobic part because of the R group. Okay, most commonly linear and even number. Okay, these are fatty acid lah. When we try to write the fatty acid, normally we write it as C16, C18, C20, macam tu. C22 they are mostly even number because of the synthesis of two carbon unit lah. And they are mostly linear. Okay, linear means the straight line gitu, But however, some has branch and odd number fatty acid also exist. Okay, especially for microbes lah. Okay, for microbes. Let's see what we have here. Okay, nomenclature for IUPAC convention, fatty acid and free fatty acid are named after the parent alkene. So dia punya group alkene group. Okay, so this is alkene group. The CH3. Okay, the CH3, 1, 2, 3. Okay, for example, octadecane and octadecanoic acid. Okay, so this is octadecanoic acid. So if you see the structure, okay, so this is where you have the carboxylic acid N. Okay. Okay, so they use the symbol yang triangle symbol. Okay, this triangle symbol is to tell you, okay, the nomenclature, where is the location of the double bond. Okay, so kalau ada double bond, this fatty acid is unsaturated. Okay, sebab dia ada double bond. Okay, so how do we know where is the location? Is to see the structure and then the symbol. So if it says delta 9 octadecanoic acid, so delta is the triangle. So it starts from the carbon number 1 yang COOH punya N. Okay, so it's here is written that, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So the delta 9 means that the location of the double bond is at carbon number 9. Okay, kalau macam ni, 9, 12 octadecanoic acid, so dia ada dekat nombor 9 dengan nombor 12, 13 ni lah. Okay, so if it's delta 9, 12, 15, so it will have at 9, 12, and 15. That's in 15 and 16. Okay. So the nomenclature is like that. That is one of the nomenclature that some people use to name the fatty acid. Okay, fatty acid also, fatty acid contain monocarboxylic acid. They are generally from C14 to C22. General saja. This is general, like mostly when you see the number of fatty acid, normally it's written as C14, C16, C18, C20, macam tu C22. But ada juga yang odd number tadi kan. Okay. Generally, even number of carbon, most abundant in food are C18 and C16. Okay. And then, of course, they have double bonds because, like we say, one is from the animal source, one is from the plant source. Okay, yang plant source ni, because they are unsaturated fatty acid, okay, normally they have double bond. So for the unsaturated fatty acid, they will have double bond. Okay. Because of this number of carbon, number of double bond, so this will affect their boiling point and also melting point. Okay, so the kalau okay, for example, I'll give you melting point kan, melting point of chocolate, cocoa butter. So that's why some company came up with apa when you eat a chocolate, it should melt in your mouth, not in your hand kan. Company apa yang pakai macam tu kan, the tagline tu. Okay, when you use a pure cocoa butter, the melting point of cocoa butter is about 36, 37. So human body is about 37 kan. So when you hold the the chocolate in your hand, it shouldn't melt until you put it in your mouth. That's why you have the satiation tadi tu. When it comes to satiation or satisfaction of eating the chocolate. Okay. If you learn like food science, normally we have this course. It's called sensory analysis of food. So when we formulate some new formulation of food, or we adjust we want to make a new product, so we will have the sensory analysis. So we will call general public to taste, to give you the taste, which one would you like, and then they will do some analysis. Okay. For this type of purposes, these big companies, they will have people who we call it trained panelists. Okay, trained panelists ni banyak guna dalam chocolate industry, and also if you're familiar, if you like to use perfume, this is not food lah, but I'm talking about sensory analysis kan. They will use this trained panelists, and this trained panelist has a very highly paid people, because they have been trained to acknowledge, macam for example, in their body or in their mind, they have their own order notes, especially for those yang involved in perfume industry lah. Normally kalau dia kan big companies will have this new type of perfume kan, so they will mix all these ingredients, and this new bottle formula, before they release to consumer, they will go through trained panelists lah. So these trained panelists will, when they smell, okay, they will know what is this formulation will have, what type of order they will have. So they know, because this human being that is being trained for doing order for a perfume company, their order notes is wider than instrument punya library. Okay, I actually many years ago, we have one professor that came from, I can't remember now. So in his order notes, dalam dia punya mind tu, he can identify more than 1,000 single node, order nodes, which is crazy. So bila dia bau je, dia tahu apa yang ada dalam that you put in the bottle lah. Okay. So that's how expensive, how much they are being paid because of that particular skill that they have. So this one lah, like one that I mentioned, the melting point too. So when those in chocolate industry, okay, they know that when for example you have upper expensive chocolate like patchi kan, tahu tak patchi? Okay, if you go to LCC maybe have IOI, I'm not sure. Okay, try to buy one patchi chocolate and then taste it and compare with apa kita ada Cadbury, we have berries lah, berries paling ni lah common. Okay, try to compare with that one and see what is the difference. Okay. So because the one that is being used, if you use pure cocoa butter, all these cocoa mass, it should melt in your mouth, not in your hand. Okay. Because cocoa butter, the melting point is about 37. Okay. Alright. I think you can go to Barrel's punya factory here if you are curious about how they make the chocolate. Okay. They actually display from outside. They have this glass wall. You can actually see the process of making chocolate. Okay. Order decrease as C number increase. So that means bila C number ni from 14 to 22, when the C number increase, the order will decrease. Okay. Let's see 12 and higher are orderless. Okay. Short chain fatty acid have marked SCFA. Okay. Short chain fatty acid have marked order, for example, acetic, propanolic, and butyric acid. Okay. They have a distinctive order, right? I'm not sure if you can see this table. This is from the Lipid handbook, Chapman and Hall. Okay. Ni systematic name and the trivial name, and this is the apa ni number of carbon lah, one carbon, two carbon. Methanoic acid or methanoic is formic acid, so dia punya carbon 1. Methanoic acid macam tu methanoic, acetic is an acetic acid, carbon 2. Propanoic acid, butane is carbon 4. Ingat tak dulu kita pernah hafal ni during our organic chemistry kan? Hexa is 6 lah, hexa is always 6. Octa is always 8 kan? Deca, nona, so these are the trivial name. Okay, we see that kita tengok start. Kalau in food, normally we start from sinilah lauric acid. Lauric acid, or it is called dodecanoic acid. It is 12. The melting point is about 44. Okay, 44. Then we have palmitic. Palmitic ni banyak dalam palm oil lah. It's 16O. The melting point is 62. Okay, 62. Then we have stearic acid, we have linoleic acid, linolenic acid, banyak lah. Okay, you don't have to memorize this. Is this information? And then as you go along, okay, for example, as the C is higher, the melting point is also higher. Okay, so tengok yang mana at room temperature. So if you see here, room temperature, katalah Malaysia is about berapa? 30 kan? 28 to 30. So anything less than 10, okay, dia tak melt lagi lah. Okay, dia tak melt lagi. So that means this one 31, 44. Okay, dia kena higher temperature for it to melt. Okay, like 52, palmitic is about 62. Okay, 62. And then the henny is about 80. Okay, as we go along, the higher carbon, the higher melting point. Okay, that's the message lah. This one is structure. This is how it is being written. Okay, systematic name, trivial name and shorthand name. Okay, kalau yang ni, dia ada dia punya number of double bond. Okay, this is number of double bond. So for example, we see lauric acid is 12O. That means there is no double bond. And then we see that palmitic is 16O, no double bond. Octadecanoic acid is stearic acid, also no double bond. So we have this one, oleic acid. Okay, 18-1. This is 9. This is the location. This is actually the location of the double bond. Okay. Alright. Okay. Structural classes of fatty acid. Saturated, unsaturated. Kalau dia saturated, meaning there is no double bond. Okay. Kalau unsaturated, it can be mono unsaturated. That means satu. Mono is one. You have one double bond, or you can have poly. Poly, you can have more than one double bond. So we call it omega-3, omega-6, omega-9. Okay. And then we also have branch or cyclic fatty acid, which is minor. Okay. So cis and trans conformation. Okay, this one is the one that we call it the location. The location dekat double bond tu kat mana dia, sama ada it is parallel or it is perpendicular. Okay. So example C9 octadecanoic acid. All natural occurring fatty acids are cis. Okay. So mostly they are cis. Tapi banyak macam kan foods like chips kan, or the one that is being used because of the reason the manufacturer have to change to the favor of the consumer for stability. Normally dia akan tukar kepada trans. Trans are more stable than cis lah. Okay. So that's why you see a lot of health, doctors, they will recommend not to take food that has higher trans fatty acid punya element lah. Okay. So because all natural occurring fatty acids are cis. Kenapa dia jadi trans? Okay. Because food manufacturer tukar jadi trans so that for the stability of shelf life of food compound. Okay. Okay, this is what. This is an example lah. Okay. Okay. So this is fatty acids, shorthand N, or ditulis macam omega lah. Okay. This omega. The number of carbon in the chain is followed by colon. Okay, yang macam 16 colon tu double dot lah. Okay, 0. The number of double bond followed by the number of double bond closest to the methyl end of fatty acid. Okay, because tadi kita tengok ada yang COOH, ada yang methyl end kan dekat sini. Sini kan. So this side is the COOH side. This one is the methyl side. Okay, so kalau macam protein, satu dia ada COH, the other one is amine. But for fatty acid, one is COH, another one is apa? CH3, methyl group. Methyl CH3 is methyl group. Okay. Okay, the number of carbon in the side chain in the chain is followed by colon, so double dot, the number of double bond. Kalau ada double bond, dia akan tulis 1, 2, 3. So 16, 3 is 16 carbon, double dot 3, meaning dia ada 3 double bond. Okay, followed by the number of double bond closest to the methyl end. So starting from the methyl end. Carbons are numbered from the methyl end of the molecule. The letter W ni, macam W macam omega, is often replaced with N. Okay, depending on how they are being written, the nomenclature. Okay. So saturated fatty acid, they are smaller, saturated fatty acid, smaller molecular weight species are water soluble but decrease in solubility as increase. Macam tadi kita tengok, if you go like higher C, the melting point will be higher. Okay, so sama macam kat sini, so solubility will decrease as the size is higher. So the higher, like C24, will have less solubility as compared to C14. Okay, that one is for the saturated fatty acid without double bond. Okay, yang dia punya belakang double dot zero. Yang zero tu semua saturated fatty acid. Okay, unsaturated fatty acid is the double dot one. Okay, kalau mono lah, mono unsaturated are mostly delta 9. Okay, delta 9 location number 9 from the dari kita tengok kalau dia tulis delta 9 is carbon number 9 from the carboxylic side. Okay, polyunsaturated fatty acid has more than one double bond. Okay, which are more nutritionally essential. For example, linoleic acid. Okay, that means yang ni yang lebih banyak kita advise to take lah, the PUFA one, polyunsaturated fatty acid. Then we have acetylenic fatty acid, ionic or dionic acid suffix with denoting acetylenic bond generally at delta 9, but these compounds are very rare. Okay, and the other types of fatty acid. Okay. And then we have trans fatty acid from bacteria or all steam deodorization and or hydrogenation. Okay, satu proses untuk buat macam tadi kan, I mentioned how to make oil, how to change oil to become more spreadable. So if you want it to be more spreadable, you have to make it more solid lah kan. Macam tadi kan kita tengok kalau kat supermarket, you have spreadable butter. It's not actually butter, it's spread they call it. But they use olive oil. Macam mana olive oil kita boleh spreadkan dia dekat atas roti. Okay. So this is the one of the reaction, one of the processing method they call it. Okay, this is called hydrogenation. Because of the double bond, macam mana nak jadikan dia single bond? So you add hydrogen. So it's called hydrogenation. Okay, hydrogenation. So that is what manufacturers are actually doing lah. Okay. Ini salah satu method. Ada method lain lagi. Okay. Kita panggil interesterification. That one part 2 nanti I will go through with you what it means by interesterification. You can mix the type of fatty acid. You don't have to do hydrogenation because bila kita buat hydrogenation nanti ada nutritional consequences. Kan nanti food companies selalu they want to have something that is at the same time serve the purpose of selling, but masa yang sama at the same time they will reduce the nutritional consequences lah because they have they have the responsibility to take care of also to take care of the consumer's health kan. Macam tu so one method is to use hydrogen. When you use hydrogen, you will convert the double bond tadi, dia akan jadi single bond lah. So bila jadi single bond, dia jadi saturated. Bila saturated, dia akan jadi more solid. More solid. Okay. Lepas tu metal branching. Ada juga macam just now we're talking about how these fatty acids are more linear, right? But there are incidents where this metal dia akan jadi branch. Branch meaning either they go up or they go down. If you see it in 2D, but if you see it in 3D, then it will go at the back or it will go at the front lah. If you see this 3D structure of molecule, right? So metal branching occurs at these two carbon. Okay, carbon yang ada double bond tu. Okay, especially isoprenoid or terpenoid biosynthesis pathway. Pathway ni macam how to produce this type of molecule lah. Okay, so dia akan jadi metal branching. Okay, let me see, you can see this. This is fatty acid structure with some functional groups found in fatty acid functional group. So you have fatty acid with saturated alkyl chain. So dia akan ada semua saturated and there's no double bond. Okay, methylene interrupted double bond. Okay, this is methylene interrupted double bond. This one is conjugated double bond. Conjugated double bond ni meaning that dia alternate, alternate single dengan double, dia alternate. Okay. So kalau cis dengan trans macam ni. Kalau cis, dia punya R group tu both located at the same we call it in chemistry, macam same location lah. If you see it in 2D, both will be the same upper part or same lower part. But if you see it in 3D, dia dua-dua ada dekat sebelah belakang atau sebelah depan kan. So actually it goes like this. It doesn't go up and down like this, but we see it in 2D. Okay. And then we have trans. Okay, trans bila dia perpendicular. Perpendicular meaning that one is that direction dia perpendicular perpendicular like this. If you see 45 degrees gitu kan. Okay. You see that way lah. Okay. So location if it is a 3D, dia the other way around. Satu sebelah belakang, satu sebelah depan. Macam tu. Okay. So that is trans. So cis is where you have both at the same position, but trans is perpendicular position. Itu dekat dia punya double bond. Okay. So like I said, if you do companies, they manufacturers, these are more stable lah. Trans punya structure or configuration, they are more stable. Okay. This one is acetylene, alene, metal branch macam ni lah. Branch dia tak aliphatic, maksudnya dia tak straight. It has branch up and down. And then we have the hydroxyl. Ni yang kita panggil yang special structure with either apa ni, triangle ataupun dia penta. Okay. So if you see something like this is cyclopropane, cyclopropene, epoxide. Epoxide ni dia ada triangle with an O. Okay, epoxide. Furan ni dia punya structure is the one that has a penta with an O. Okay, these both epoxide and also furan, these are all considered food safety punya issues lah. We don't want to have this in our food. Okay, this have to be monitored. Kadang-kadang epoxide and furan ni they happen from it normally it doesn't happen in nature. It is being formed after the fat is being processed. Contoh, for example, epoxide ni dia jadi dalam proses refining of oil. Okay, epoxide furan pun sama lah. Dia macam furan ni mostly happen bila ada combustion furan. Normally it's being monitored. Kalau macam in environment, normally it is being monitored at certain level lah furan. Okay. Okay. And then this one is unsaturated fatty acid in fats and oil. Okay, ini adalah systematic. It is the systematic name. Okay. This one is the location of the double bond lah. Okay. 9-decanoic acid, 2-decanoic acid, and then dia punya writing tu 16O, 16 dia tak tulis kat sini ya. Okay. This is number of carbon 10, 12, 14. This is the common name. Linoleic acid, oleic acid, linoleic acid, okay, linoleic acid, linolenic acid. These are all PUFA lah. Linoleic acid ada 2 double bond, linolenic acid has 3 double bond. So 18-1 is racemic acid, 18-2 is linoleic acid, 18-3 is linolenic acid. Ini yang common punya you have to know. Macam linoleic acid, linolenic acid, oleic acid, palmitic acid, macam the common fat lah. That one you have to know. Alright, so these are all the melting points. The higher the melting points, okay. But the more saturated, the melting points is lower lah. Okay. Typical fat source. Okay, this one is in butter fat. Palmitoleic acid 16O, mostly some fish oil, beef fat. Ni tengok kat mana where you can find the type of fat. Okay. Kalau arachidonic acid, dia ada 20 and 4. This one is in lard. Okay. And then linolenic